Good afternoon, I am Mr. Ish. Thank you for joining me for this interesting video. We're looking here at basic organic chemistry, benzene concepts. We have to moderate the amino and the hydroxyl groups on the benzene. And why do we want to do that? Why do we want to make these less activating than they are? Because if we do not, then your benzene ring is so activated you can get a bunch of side reactions that you do not want. If I have either aniline, which is aminobenzene, or I have hydroxybenzene, or you can call this phenol, either or. These circles right here represent a resonance structure which accounts for all the varieties of resonance structures of benzene. It's a shortcut way of doing it. Anyhow, if I have either of these and I react them in the presence of bromine, you don't even need a catalyst because that's how activated these are. You can have, let's just pick any of these, we'll pick the aniline. You can have excess items bind to your benzene ring. You can have Br over here, you can have Br over here, and you can have Br here. In essence, you have 3 bromine atoms attached. You would have only wanted 1, but you are getting 3. And the same result with the OH on your benzene. That's how activated these are. You don't even need a catalyst, but you have multiple items adding when you really only wanted 1. So then you have to start thinking about moderating these, meaning you want to start weakening them. They're less activated, they're deactivated, so your benzene ring will give you the type of reaction you want. And you can. If you're looking at this, you can deactivate it by converting it into an ether. You have a hydroxyl group, you can convert it into OCH3, which is anisole, but you have added a methyl group. By adding this methyl group and converting into an ether functional group, you've made the benzene less reactive. Now when you do your bromination reaction, and you can get your desired product. Now I'm writing here desired product. You get your 1 item of bromine, add either to the para or ortho position, but you will have deactivated your hydroxyl group. And how would you convert from here to here? You can. You would basically react it with methyl iodide, CH3I, in the presence of a base like sodium hydroxide. You can convert the hydroxyl group into that. If you want to go backwards, you can. You want to get rid of that CH3 and go back here, you can. And the reactants you would use for that would be these. You would just use a hydrogen iodide in the presence of acid and you would reverse this reaction, but you have deactivated the hydroxyl group, you've moderated this and converted that into the ether group, and likewise you can moderate this as well and make it less activating. So let's show you that. Then I'll show you a single reaction for this video and that'll be it. To deactivate this, you want to convert this into some form of an amide, and we can't say amide, but it would be a amide with some sort of a functional group, Fg. And what will we use over here? We'll use pyridine as our solution, and we will use acetyl chloride. Acetyl chloride. What does acetyl chloride look like? CH3 C double bond OCl. CH3 C double bond OCl. Rather than a OH group over here, you know acetic acid would be CH3 C double bond OH. We have brought this, we have converted that into a chlorine atom, a acetyl chloride. We can deactivate this amino group or make it less active and generate a form of an amide functionality, and it would be NH C double bond CH3, and then you would have your benzene item over here. What would happen here at the presence of this chlorine? It would be lost, and at the C double bond O, you'll attach it with the amino group, the nitrogen, so you've developed here an amide functional group. That's exactly what it is. Now this is less reactive, and if you were to now attack it in an electrophilic attack with regards to bromine, you'd have your desired end product, DEP, desired end product, meaning a single mole of bromine will attach, a single atom of bromine will attach to your bromine versus 3 of them. Anyhow, now you've seen how you can moderate the amino group and the hydroxyl. This is converted into a form of an amide. The hydroxyl group is converted into a form of an ether, and now the groups are deactivated or less active as they were than before. Let's look at our reaction for this video. I have aniline. I'm going to attack it or react it with pyridine in the presence of acetyl chloride because I want to deactivate this, or I want to make it less active than what it is. And now I'm going to generate this NH. If you want to demonstrate it properly, you're looking at this hydrogen here, and then you have C double bond CH3, C double bond or your carbonyl group, your amide bond is over here, and then you have your benzene ring. This is it. Now you've generated your moderated amino group on the benzene. This right here is really called an acetamide. Just for your purposes, acetamide, because there's an amide functionality and there's an acetyl group, acetyl with an amine, acetamide. And what's a amide group? It's a C double bond O, a carbonyl with a nitrogen. That's your amide functionality right there. Let's look at the next step of this reaction. I'm going to react this with SO3 and H2SO. Why am I doing this? Because I'm blocking this area right here. I want to have a reaction such that I don't want anything to happen to para position. I don't want my end result to be in a para position. Keep in mind, hydroxy and amino groups are ortho-para directors. They'll add to ortho and para. I don't want to have anything add to the para. My end product should only be either in the ortho position. So I'm blocking the para with a sulfonic group. I'll have this NHC double bond O CH3. I have my benzene ring, and I've added a sulfonic group right here, HSO3 or SO3H. Either way, SO3H or HSO3, doesn't matter how you write it. Now I've blocked this position. I want to nitrate this. I want to bring a nitro group, so I'm doing HNO3. And now I'm going to nitrate this ring. I want to bring either nitro group to the ortho position. It's going to add either right over here or over here. 1 mole of nitro group will add either there. It's the same position, it doesn't matter. So this is what I'll get, NHCOCH3. I'm just showing you in that way. I have my blocking group over here, HSO3 or SO3H is the same, and my nitro group. Now what I want to do is get rid of this blocking group, and I want to get rid of this protecting group and end up back to an amino group. How can I do it? Well, there are two procedures. The first procedure, you'll do water and acid with intense heat. What will that do? The water in an acidic environment and intense heat, it will get rid of this. Then your next step will be to get rid of this amide functionality, and you can in the presence of water and base. The base will get rid of it, and then you'll end up exactly with an amino group, NH2, but you will have over here your nitro group here in the ortho position, NO2. Now, that's our end product, and we're done. This right here is the better way of doing it. If you took this and you nitrated it, you could end up getting a nitro group here, but you could also end up getting it here, and you could also end up getting here, and you may not have your mono-nitroaniline, or you can say your 2-nitroaniline, but it's still mono because you only have one item of nitro on your benzene. You would have had tri-nitroaniline, and that's not what you wanted. You wanted only mono-nitroaniline, and that's how we did it. We brought a moderating group to weaken the amino group. We brought a blocking group to block the para position. We used the acid and heat to get rid of the blocking group after we've nitrated the benzene, and we brought in the base and water conditions to get rid of our protecting group, which is your amide functionality. Your acetamide has been removed and reverted back to your aniline, your amino group, and this is how we do it. This right here is a reversible procedure. The sulfonation is a reversible procedure, and the end result is exactly what you wanted. And that's it for this video. Thank you.